Waiting for LLM Engineering AI. Refresh करूँ ऊपर से YouTube ओपन आती है तो बोला है. Hey guys, so guys, finally we have started this initiative this year. So end of the 2023, uh, the scene is in the mind that like LLM is so on the boom. Okay, and I saw that a lot of messages from the people that they are trying to figure out some courses and everything. So due to that, I found that like why not we can start our own community course, and during that course we can teach not directly the LLM but with the basic NLP. So people even who don't know the NLP can take in the participation inside that. So today's theme, as you all know that like we are constantly spreading out the messages into the group. Like me and Vedant both are spreading out constantly the messages in the CBNLP group and other groups. We have spread the message on LinkedIn, Instagram, whoever who want to join these NLP engineering learning era and LLM engineering learning, that we are open to share that link with anyone, but we have a basic limited strength, right? So we have initially started with 200 registrations, and we are happy to say that like we crossed the 200, and that registration is like I got a overwhelming response from you. And now I am welcoming all of you to join this NLP journey. And today's first session will be conducted by the Vedant, who will explain us the foundation of the NLP and like what is the fundamentals and what is the journey and what is the history of NLP. So we are starting from zero to end. Zero to end means something like which is a core concept of NLP, and we are also able to see the code of each and every concept. Okay, so I will just hand over to you, Vedant. You can just give your introduction and also share some thought about this journey, and then after you can start this. Thank you.
Yeah, so hi guys, I hope I'm audible.
Yes,
Good
you are.
afternoon. Thank you. Okay, so good afternoon, guys. This is Vedant Pandya. I'm AI researcher and machine learning engineer since last 3 years, and I'm based in Gujarat. So I am a part of this community since Ashish introduced that he is going to lead this kind of things. So I'm happy to hear for the first session, which is an kind of introduction, or I can say let's get started to the and now let's see the how the things goes like from where we have started, then what happened, and now where we are at. Okay. So let's say let me introduce the community first. Hello, this is Vedant Pandya once again, and we are presenting you from the core concepts of LLM engineering. I'm once again welcoming you guys for the LLM engineering community. Okay, so we are thrilled, as Ashish said, to have you join us for today and to start the insightful addition to your NLP knowledge. Okay, so this session will be mostly aimed, I can say, to reveal the mysterious or the core concepts of natural language processing. Throughout the session, we will uncover the power of different methods, history, And so, yeah, uh, for the cutting edge technologies, we will going to look at it. So this is Vedant Pandya once again explaining about introduction and natural language processing with Ashish Patel and powered by LLM Engineering Community. Thank you. Okay, so what will be the agenda of this? This session for the first time it is going to be in four different parts. First is defining NLP, that what is the I can say the domain is. The second thing is evaluation and trends in NLP, since it's in I can say the introduction to the world in 50s, then the applications of NLP, and then the challenges and limitations we are facing right now. Okay, so let's kick off by unraveling the core of NLP. The first is, as I said, the defining NLP. So the definition of NLP, or the introduction, I can say, is something which revolves around the basic of computer science, intelligence, artificial intelligence, and linguistic programming, focusing on enabling machines to comprehend, interpret, and iterate with the language-based interactions. Then the LLM engineering is a community of like-minded peoples empowering minds for the field of artificial intelligence. We have 800 plus active members, and this is the first, I can say, the first session we are hosting like this. So we share insights, we share knowledge, we share updates or trends in the uh, I can say this community with unleashing potentials. So to become after being in part of this community, you can get into interactive sessions like this, which is possibly is led by the industry experts, and where our motto is where curiosity meets expertise. So we have community members differing from students to early career professionals to mid career and the seniors as well. So we have this opportunity and community with hands-on experiences where guys can experiment with a lot of things by becoming a member. Okay, so for the next thing, what is the big picture of NLP is looking like? Okay, so a big picture of NLP is something that is going to be the core, which is like you're giving it to this branch, then this branch, then you can explore the other branches as well. We will obviously we will share this images and resources with you guys, so you can handle this and you can go through this on your own as well. Okay, so let's talk about the first thing, which is defining NLP. As I said, it is simple, I can say, introduction or the thing which is, yeah, okay. Am I audible? What is it?
Yes, Vedant, you are.
Sorry. So let's start by defining NLP. Sorry for the inconvenience, guys. The first is that natural language processing is the intersection of three things. First is computer science, second is artificial intelligence, and the third is linguistic programming. These three parts coming together to, I can say, to form this field of NLP. And focusing is this is what is yeah this is focusing mainly on language based interaction between humans and computers. It is the technology, or it is the bridge between machines and human languages, I can say. Then the let's get into the next part, understanding the essence of natural language processing, which is the I can say the main meaning of this. So first is the decoding language. Natural language processing is mainly the art of decoding languages by machine, or we can say teaching machines to understand and interact with human language. The second point is telling is that language mastery in the realm of NLP, we can say the machines are going to become an intelligent as human, to understand and to interact with humans in the human languages. And the algorithms unravel the intricacies of language, enabling machines to comprehend, interpret, and respond intelligently. Like a human is interacting with another human, it is working like that right now. Okay. The next part is conversations with machines, which is like the I can say the example of Chat GPT, because natural language processing now goes beyond the words, and it has empowered the machines, or I can say the models, to understand what a person is saying, what is the I can say the sentiment behind that. Is it sarcasm? Is it a negative thought, a positive thought, or whichever it is? And the main thing in this is it is now somewhat capable enough to learn it from the humans and interact with humans as well. So, and the fourth one is that it is now able to get insights on its own from texts or PDFs or documents, whatever we provided. Let's say we have GPT-4, which can means get the orders, or I can say, which is let break. Yeah. Why it is speaking. Okay. So, which is like working on its own. We just provided I can say the documents or whatever we want in terms of PDFs or CSVs, and it can like get the insights for us. Let's say we have provided a research paper, and we told ChatGPT that summarize this research papers for me. Then it can give you the insights which are present there in the research paper. Okay, so moving forward, the real world applications. So right now, the real world applications are going to be like the what we are seeing right now, and what we can do from this real world applications. We have categorized this in this three categories. First is generation, which is either it is a text or images. The second is machine translation, and the third is personalization. So as we can see, the first category, the generation, is going like personalized news feeds and content creation. Like it is in the recent trends, uh, we have seen the generative transformers with multimodal inputs, models like GPT-4, GPT-3, GPT-4, GPT 3.5 Turbo, Jurassic 1 Jumbo are being trained on diverse data, including texts, images, and audios. The recent addition to this is the Gemini models by Google. Then this things allows us to generate personalized content, personalized views, and summaries to adapt writing styles if we want to get into something, to user preferences. So it is giving us the contents we like the most, or we are used to perform consume it, I can say. And then you can create your own contents as well. Like let's say you have given a prompt to chat gpt that you want to write an essay on this any random thing, that it can write it for you. Let's come to the second category, which is machine translation. This is kind of a revolutionary thing for the field of natural language processing, because this can enhance the knowledge base of machines on its own without any human interventions, or without any supervision of human, we can say. We just provided the data in any form, in any language, and we can translate it to whichever language we want, or we can translate or transform it to whichever kind of data we want. Let's say we have provided it with a CSV file which contains factual data of pricing inflation, and let's say we told it to transform this data into a report or a chart, then it can do that as well. So the second thing mainly focuses as of now is on the medical chatbots. And language support for healthcare professionals. Like let me give you an example of this. As we all know, by being an Indian, we can't easily understand the handwritings of doctors. Just a chemist or a person from a pharmacy background can understand what the doctors have written on the prescription notes. So by by addressing these issues, now the doctors using the machine translation to prescribe computer based prescription, we can say. And context aware biomedical transformers are recent buzz in the medical field. By it is by medical associations, for medical associations like this. And it provides us a clinical records as well, that can be translated from a medical document or a conversation. The next category is multilingual NLP. So the as you can see, the application is disaster response and multilingual information aggregation. So by doing cross-lingual transfer learning or zero-shot translation, and by utilizing these models, we can leverage the knowledge from the one simple explanation or explained image to understand another. Let's say a person who don't understand English can utilize this multilingual natural language processing to convert it to another language which he or she can understand very easily, and with I can say much ease, he or she can put it out. Okay, so the next topic for us is evaluation and trends. So let's start from looking at history, what history tells us. So historical perspective is very much, I can say, important here for the field, because the history from where it was, what it has gone through, and where it is right now is something which we need to understand first. So before we dive into the uh, history as it is, let's begin the understanding of its timelines. The natural language processing firstly introduced in the 1950s, so it is not something which is, I can say, uh, evaluated in just last 2 years or 3 years. So let's embark this journey through the decades, tracing its evaluation from 1950s to 2000s first. Okay, so in the early years, the focus was on machine translation, because at that time, it is like from one language to another, which we were doing it right now as well. Then it was pioneered by Warren Weaver. The second decade of 1960s witnessed rule-based systems attempting to understand the language structure. Then in the very next decade of 1970s and 1980s, moving into it, the statistical methods gained prominence for this. And the main, I can say, the pioneers of this research is Karen Spark Jones and his team. So, researchers exploring the probabilities of word sequence, the uh, intriguing, I can say, the methods for statistical models to build upon. The next decade of 1990s brought about a shift towards more data-driven approaches, paving the way for applications like spell checkers and early chatbots. And in these, as we entered the 2000s, the advent of the internet and the surge in digital content opened a new possibilities. Breakthroughs in machine learning, fueled by major or a vast kind of data sets, which includes almost every single domains and its knowledge, set the stage for the rise of modern NLP techniques, including the transformative impacts of neural networks. And this is where Jeffrey Hinton comes with the deep learning era. Okay, then let's say that we are in the 21st century as we stand on the cusp of a new era. The journey from rule based system to sophisticated deep learning models showcases the relentless pursuit of understanding and enhancing human language as well, to an extent which we can say, probably it is from just writing texts to human interactions right now. The historical perspective cites the foundation, and for the strides we continue to witness in the field of NLP. And as we step into the 21st century, the evaluation of natural language processing kind of accelerated unprecedentedly, or unprecedented momentum was given to the researchers as well. So in the 2000s, the rise of large scale data set and computational power set the stage for statistical approaches, like it is enhancing both in the softwares and on the basis of hardware as well. The stage for statistical approaches and techniques like support vector machines and conditional random fields brought advancements in tasks like named entity recognition, and sentimental analysis. In the very next, I can say, the decade, we witnessed a landscape which is transformed with advent of deep learning, neural network architectures, and especially recurrent neural networks and long short-term memory networks, which is known as this is the these things we can say revolutionized large language modeling, which we are exploring right now in the 2020s. Okay, so the introduction of word embeddings was made, like word2vec and glove captured semantic relationship, propelling natural language processing capabilities to another level. The particular year of 2014, where the world witnessed a groundbreaking moment with the introduction of neural machine translation (NMT). This approach, leveraging deep learning, brought a whole paradigm shift in machine translation, and specifically improving the quality and fluency of generated translations, I can say. As it approaches the end of the second decade of the 21st century, in 2020s, OpenAI released GPTs, and Google came with its transformer based model BERTs. So now it is these models fueled by attention mechanisms which excel in understanding context, enabling and breakthroughs in natural language understanding as well. It is not just like it is generating some texts, or it is like building a chatbot simply. But transfer learning becomes a cornerstone now, I can say, and allowing models to language, allowing models to leverage. Why it is blinking? To leverage a pre-trained knowledge and vector basis. And as of now, NLP stands at the forefront of achieving AGI with innovations and applications ranging from conversational AI to language translation and content summarization and whatnot, we can say. It is more like content based models now. Okay, so let's talk about the current trends, what we are seeing right now. So NLP is seeing a dynamic trends shaping its own landscape. Like the first is transformer models, which is continuing to dominate with Gemini versions like Nano, Pro, and Ultra. GPT-4, it is exemplifying the unparalleled language generation capabilities, which is huge, I can say, advancements in the field of NLP. The multimodal AI integrations combining text, images, voice, and the reply in speeches is pushing boundaries and understanding context now. So we have, we can say, we have this categorized in five different categories, which are present here. The first is beyond bigness, which quest for advancements, that the focus is shifts beyond sheer model sizes. Beyond bigness emphasizes the efficiency, encouraging the development of compact but yet powerful models, just like current quantized models of llama, which are 3 billion, or tiny llama with just 1.1 billion parameters. The second thing is the multimodality, The NLP is, I can say, embracing the multimodality and transcending itself from text only understanding to becoming more nuanced comprehension and interactions with diverse form of information. The third is the reinforcement learning and interactive natural language processing. As reinforcement learning takes the center stage, introducing interactive elements to natural language processing. Models are now just not understanding, but actively engaging with a user and learning through interactions as well, which is like a next level thing for NLP, and more dynamic and adaptive approach to tasks has given. The next category is fairness and ethics focus. So the NLP landscape is also being matured with the intensified focus on fairness and ethics. And in simple terms or a layman terms, we can say a biasness as well. So, as the community recognizes the impact of artificial intelligence on society, efforts to address bias, ensure transparency, and upholding the ethical standards are at the forefront of development for NLP or large language models right now. The last category of trends right now is democratization and collaboration. As we embark on the NLP journey, let's say uh, we are witnessing code llama 2 or llama 2 architectures or many open source like mistral models, mixtral models as well, which is moe in on its own. So there are different models present, but democratization of large language models are a current trend, and a most soothing one is always because GPTs are owned by OpenAI. The Gemini models are owned by, or a text bison, I can say, who is owned by Google. But in this field, the companies like Mistral, Meta is still providing uh, democratic large language models, we can say, that anyone can use for any purpose. The purpose doesn't matter, either you are using for your own purpose or either you are using it for your commercial uses as well. So the next thing is applications of NLP. We are having different real-time applications, but there are a list of applications exploring diversity in various industries as well. Then let's start with the sectors or the industries. As first we have healthcare, then finance, and in finance the NLP is doing great in terms of enhancing the financial analysis, fraud detection techniques, and customer services through the sentiment analysis. And there, I can say a review one. In the next sector, which is e-commerce, personalizing user experiences or improving search functionality, utilizing artificial intelligence and natural language processing behind a curtain, which eventually boosting customer engagement and its utilization of that platform, we can say. The next thing is legal. So it is helping this industry or the domain, we can say, in terms of various aspect like contract analysis or document summarization or increased efficiency in the legal domain or the legal research streamlining. There are multiple explorations in this as well. Then we have customer services, as I told you before. Customer services are transforming interactions with sentiment analysis, automated responses, a menu-based chatbots, or I can say a personalized support in the field of this as well. Then we have put the marketing here. So, as we know, the artificial intelligence and the natural language processing or large language models can create your own contents. So, there is an obvious part of marketing, which is a content creation. You can create your own content by utilizing natural language, large language models. Then we have sentiment analysis. If we are running marketing campaigns through whichever platform like Google Analytics or Google Ads or Facebook ads, the reviews we are getting, we can analyze those sentiments for a brand perception, that how a user or a market is looking up ahead or around this product. Then we can also do the target based advertising for the target audience. Then we also can leverage the language insights as well. Let's say we are creating a product which is going worldwide, but we don't know every single language they are speaking. We can utilize this at that as well. Then very nuanced field, we can say, education supporting language learning. It is you getting used by Duolingo right now. Then we can utilize it to grade, automatic grading system. We are utilizing in providing personalized feedback to a student. We are also utilizing it to create a roadmap for a student for this. And even not only for students, it is revolutionizing education system for the educators as well. They can leverage these things for teaching as well. Then we have the next category as human resources. So streamlining recruitment processes, analyzing employees feedback, improving HR communications, and many more categories are there uh, in the human resources. The next is social media. As we can see, our we all are using Instagram. We all are using Facebook right now, WhatsApp, Google, analyzing trends on this, analyzing sentiments, analyzing user interactions, and by analyzing this much of data, we targets the marketing and content recommendation. As a model behind a curtain, it is working to generate recommendations for you. It is always generating recommendations for you. It is like going far beyond than the imagination that what will come next. Okay, then let's talk about case studies we have right now. So the the case studies are majorly in the from the categories which we discussed earlier, and the this case studies leads us to the challenges and limitations we have right now in the domain of natural language processing, which can be also categorized in the I can say five subcategories, which is like this. The first is ambiguity, which is an kind of intricate dance and of ambiguity in context of language. The second is data quality and biasness. The third is multilingual understanding. It is still in the learning process. Dynamic language evaluation and semantic ambiguity right now. And the next is discussing the limitations and ongoing research areas, which is the field to explore as of now. This leads us to the uh, works like it is how the current system is focusing, or how a current system of large language model functions, that it can uh, get us through the stage of common sense understanding. Or let's say we are the large language model is still unable to grasp some sarcasms, we can say, to explain the lack of common sense understanding. The second thing is excessive resource and requirements to governments, as a large language model is a resource intensive nature of training, and fine tuning large language models also requires some great amount of computational resources. And it is also raising questions around environmental sustainability, carbon emissions, and that as well. That gets us through the third category, which which is used mainly for addressing biasness within the large language models, and it ensures the ethical deployment in the critical aspects of ongoing research and attentions. That uh, on the fourth thing, which is interdisciplinary integration, it is used, or it is a field of bridging the gap between natural language processing and other disciplines, as neuroscience or psychology. uh, and this is an ongoing challenge as of now for a more holistic language understanding. For this, we can utilize a multimodal things by giving it eyes and ears to this. And the last is robustness and adversarial attacks, which is it is strengthening large language models against the adversarial attack and ensuring robust performance in scenarios. It's a continuous area of exploration as well. That gets us to the end of this introductory session. Sorry, it is just like a theory. But yeah, the thing here is to
Just
uh,
like a theory. But yeah. So, guys, platform is open for asking the question. You can put your question in the chat. We are taking over here, and yeah, we can directly ask the question to the Vedant. If you have any questions, you can directly ask straightforwardly in the chat, and we will showcase your message, and he will answer. Guys, come on! If you have any questions, don't hesitate to ask. Guys, come on! If you have any questions, don't hesitate to ask. Okay, so Vedant, I have one question.
yeah.
So, why NLP basics is basically the necessity to learn LLM
Yeah.
engineering.
Okay, so let me give you an example. It is like I can't get admission directly into the engineering, right? So it is like we can teach a person how 100 plus 50 is going to 150, but for teaching that, we have to teach how 1 plus 1 is equal to going to be a 2. Without a core concept or a base, we cannot teach anyone, or we cannot even explain anyone.
Okay.
Yeah, so that's why the introduction is kind of a necessity to explore any field or any domain in the terms of artificial intelligence. Either it is a means in terms of NLP or computer vision or multilingual natural language processing, whatever it is.
Okay. So guys, please don't go. The main session will start now, and the main session I am going to represent. So if you want to take a 5 minute of break, you can take it. And after 5 minutes, we will start again the session two, which
Yeah.
is include the basics as well as the same time. I think we all have, so like you all got the GitHub link, right? So we have already shared the code with you. So I will showcase you the theory, and its practical part is like what is a theoretical section, what is tell us, how to learn it, and we understand the core idea, and same time we are also do the code for the same. So second session will be on that. So
Okay.
take a 5 minute of break.
We have some
Okay.
more questions in the comments as well.
Oh, that's great.
Yeah. So this is the question from Jai Joshi. His question is, what type of project will make you stand out in NLP domain? Okay.
Great.
So the very first category to stand out in the
Mhm.
NLP domain is you are building it from scratch. You are not utilizing any pre-existed code or pre-existed neural network architectures. You are building your own in terms of codes. You have your own data, you have your own kind of problem statements to solve, and by doing this is going to stand out more rather than you are utilizing and experimenting a pre-existed Kaggle notebooks or Kaggle dataset. Just like no one is like to see uh, Titanic datasets for data analytics. It is just like that, that you are not utilizing any pre-existed codes or pre-existed neural nets which are already pre-trained on the that will make you stand out in the NLP domain the most.
So Jay, I have also this like similar answer, like Vedant have. So for stand out in any specific domain, first of all, you have to define your area, like on which industry you are working specifically. So let's say you are working with a legal judiciary industry, or let's say you are working with a content industry, social media industry. So obviously, the core area of the data is a text, right? So when you have a core data of area is a text, you can utilize this NLP knowledge there. So that define your NLP domain, right? So how? So let's say you start working with a lot of data, which is in the basically the document format, text format, or let's say in any structure sentence format, right, or unstructured sentence format. So that is ultimately your core area of the data. Now, uh, deal with that kind of the data is basically help you out to like taking the insight from the data. But which domain that help you out? So on that context, natural language processing is come into the picture, and that way we are totally define each and every use cases with the help of natural language processing techniques. So and that decide like okay, you have to stand out for the NLP over here. That is maybe I have tried to
Yeah.
cover it.
So
Second
we
question
have,
we have
yeah,
is a
it is
Jose
from
Maria.
Joe. So can you explain a little bit more about the use case on healthcare? Thank you and
Yes.
excellent presentations. Okay, so I have worked on a use case. I can share it with you. So in terms of NLP, we have gathered Indian doctors' handwritten prescriptions. We have trained a model on that, and we have created a system which is obvious a personal use by a company, which can just you have to scan from your camera, and it will give you what a doctor has prescribed for you, and on the basis of that medicine and the information given to the language model about that medicine, it will means kind of give you the dose, examine, and it will give you more kind of an explanation that how this medicine or how this tablet is going to be a beneficial for you if you are going through the symptoms like this. So you can means kind of verify it if your doctor has prescribed it right or not according to your symptoms as well. I have worked on this use cases, so means I know how this is. This can be a revolution in the healthcare
Hmm.
sector as well. Now, a doctor cannot prescribe any medicine because you are not getting it right. If you are not getting a fever and if he or she as a doctor is prescribing you a paracetamol, it is not going to work. So now you can cross question a doctor as well, that it is not going to be a safe for me. Why you are prescribing this? It is more kind of a that use case, that a more power is in the hand of users right now. This is
Yes.
how an NLP and computer vision combining these two features or these two domains is revolutionizing the healthcare sectors.
Yes. Great answer, Vedam. So next question from Nasir. Nasir have a question is like, can we solve any kind of the problem related to text data with NLP? So Nasir, basically when
Absolutely.
previously this natural language processing domain is basically known as a
Sense domain, I
text
can say.
mining. So most of the people is learning the data mining subject in their most of their curriculum in engineering. So this subject is basically known as a text mining. So whenever you have a text data, obviously NLP is coming to the picture because ultimately the text is belonging to the natural language. So yes, every type of the text data problem we can solve with NLP. If you have Vedant any answer, the same.
Uh, yes, the manner of my answer will be the same as well, because if you have your data in text, either it is in any kind of documents, either it is a Word document or a PDFs or just a raw data in the extension file of .txt, like that, we can say. If you have any textual linguistical data, you can solve it with the NLP. We don't structurize, or we don't means, while we communicate with each other either by any medium, we don't structurize the data. We just communicate in our we can say, if I'm not wrong, right?
Yes.
Then if the text is included anywhere, you can solve it by natural language processing. It's that simple.
Yes. Okay. Next question we have from the Rushabh Patel, who is current. He has a question. Is like currently I'm working life science
Working in
domain and
life.
facing a issue of special characters, Latin in attachment or the file names in the abstract. Does this NLP help?
Yes, if we have a pre-trained model on the fonts, or we can say a scannings of Latin and special characters, this NLP can easily solve that problem. If let's say we have, as I said, we have some different languages. Let's say we are translating from English to Chinese Mandarin, then it is not going to become be the same one, because we know Chinese as a symbols and we know English as an alphabets.
Yes.
We have pre-trained models for both of this, that if alphabet, how it is going to be represented in a terms of symbols of Chinese Mandarin. Let's keep it that simple. So yes, we can the NLP can help, and we can solve this problem as well. Thank you,
Okay.
Rishabh.
Rusa, so basically this is an encoding format. So with the help of latest large language model technology, like let's say we have a ChatGPT, which is ultimately known as one of the biggest large language closed
Exactly.
source model. So you, with the help of utilization of that pre-trained model, you can solve this problem very easily. I hope we have given the answer of all of the questions. Thank you so much, guys. Like within a 2 to 3 minute, we will start the second session, which is basically the foundational of NLP, how natural language processing is evolved. So evolved is already we know, right? But what is the language analysis? It's like how language build, how you can understand the language. why we are speaking a particular words, why we are not taking the some other words like that. So within a 2 to 3 minute we will start the second session. Thank you, Vedant, for
Thank
amazing
you so much,
session.
Ashish, for having me. And an insight for you guys for the second session. It is not going to just explanation kind of thing. You guys have the hands-on experiences in this as well. So
Yes.
looking forward to the session by Ashish.
Yeah, thank you,
Thank
Vedant.
you.
So, guys, during the session, this is our first try ever we have done. So, if you face like okay any mistake or anything, please pardon us. And like anything is something like that we are doing a mistake. Please forgive us for that purpose. We are trying to do our best as much as to just give the best content delivery to you. So yeah, in this session, fundamental of language analysis, we can also do the code as well. Okay, so whatever link I have already said in the email. Please try to check out. Inside that you will get NLP session folder, and over that you will find a session 2, and you will get all the notebooks. Okay, so notebook is there already. So within a 1 or 2 minute we can start this. Okay, so you can take a break and come back again. So guys, I have shared one basically the GitHub notebook with you in an email only, right? So try to find out that GitHub. You can find the that coding notebook and everything. And this session is totally I will deliver in a one of the easy language. If you don't know about the NLP, that's totally okay. So this is a basically I am giving in the way that like you can understand in a very easy language. So basically here our main motto is to just aware you with the basic concepts and a simple way. So that is our motto only. So we will not go into the mathematical concept, a complex mathematical concept behind that a particular concept name. We are just showcasing you like what is the concept, its definition, how it's performing, and what is the example. And then after we are directly moving on the code. Okay. So 1 more minute for the break, and we'll start soon. So guys, from you there are a lot of there are a lot of friends of mine who are constantly interacting with me. So you all are so your suggestions are welcome in the chat. You can provide your suggestion in the chat as well. We are just putting your suggestion on screen and discuss with everyone. And yeah, we will also thankful of yours that you are just constantly providing us the support now. So there is a surprise in upcoming sessions, and the surprise is like big organization is join us. That is still discussion is going on. So once we will get the confirmation from their side, we will announce soon over here. Okay, guys, let's start the session 2. So you are able to see that like natural language processing application in the real world industry. So we are using a chat to we are using a chat GPT, which is now the part of our day to day life, right? And except that there are a lot of other tools. Let's say you are using Bard, you are using a Made Journey where you are just typing the tags and you are generating the images. So like these kind of the AI tools, or we can say the generative AI tools, which are become the core part of our day-to-day life. So, do you ever feel that like how it works, why it is so natural? Whatever you ask the question to them, it is giving the so nicely the answer of that. Right? Sometimes we feel that like it is understanding us better than human being because this is a kind of natural language system which is understand the context. Or sometimes we feel that like okay, when I discuss with the chat gpt, I feel that like chat gpt is my friend. He is understand me so naturally because it's understand the natural language processing, so natural language. So yeah, so but do you know that how this language and our language is working and what the core thing that make it so powerful?
Natural language.
So
So yeah. So, but do you know that how this language and
so basically so the in second session we are basically discussing about the fundamental concept of language analysis. So good afternoon everyone. We are diving into the captivating world of natural language processing where computer learns to understand and interact with the human language. So think of it as the wizard behind your favorite voice assistant, right? As we had discussed, chatbots or even language translation apps. So imagine the world where machines not only comprehend our words but also respond with a human-like understanding. So that is the power of NLP. And today we are trying to reveal the fundamentals that make it possible. And now let's kick off our journey by understanding the building block of language analysis, where computer decode particular words and we use in our everyday to day life, right? So basically, in this session, we are just defining these into the basically the core, basically into the core three modules, and in these three modules, we are able to see that like what is the language analysis, what is the level of language analysis, real world like text representation and real world connection. So our first stop is understanding the different levels at which we can analyze a language. Think of it like a peel, you are peeling the onion. So there is a three layers. Okay, so just here imagine that you have a level of language onion. Okay, and you are just trying to peeling that onion. So from basic sounds and words to the deeper meaning and the context. NLP help the computers to make a sense of it all. So it is like you are teaching the computer to understand the language just like we do. Okay, so how we can connect these concepts with the real world? So consider your smartphones as a voice assistant like Siri and Google Assistant. When you are just asking the question and they analyze the word, their meaning, and even your tone to provide helpful response. So that's the magic of NLP at the level of language analysis. Let's say text representation. So now just imagine we are represent language in a way that computer can comprehend, just as we use a letters to form a words or words to create a sentence. So NLP transform language into the format machine can understand. So it is like teaching a computer a new language, a language of the numbers and the patterns. So let's say you want to think same text representation in real world is like, let's say think about how your email spam filter works. It is analyze the text from incoming emails representing the language in a numeric way. By doing so, it can distinguish between the regular message and those pesky spam emails. That's power the text representation in accents. And third one is a language modeling. So language modeling is lastly, so like it's like imagine the predicting what comes next in the sentence. So when you are doing a Google search and you are just typing some words and it is showcasing that like okay, there may be a chance of these words. So it is showcasing a lot of suggestions, right? So that is known as autocomplete suggestions on your smartphone or your predictive text in messaging apps. So these tools are trained with a language model to anticipate and suggest what you might want to say next. So it is like having the digital writing right companion that understand your style and competes your sentences. So this is basically the three fundamental concept we are trying to learn today. Okay, so first fundamentals is a language analysis. Right. So let's unravel the layers of the language analysis. So this is basically like how computer breakdowns and understand the way we communicate. So it is like teaching a computer to decode the secret of the language. Okay. So get ready for the adventure. So this is a first layer. So here we can say that like a level of the language analysis basically divide into the basic four parts. Okay. First one is a morphing. Sorry, morphology. So morphology is known as at the basic level. So think about building a block of language. The smallest unit like sound, prefix, suffix. So morphology is like the ABCs of the languages, which helping the computer to understand the structure of word. Second one is a syntax. So let's move the level to arrangement of the words. So how they come together to form a sentences. So syntax is nothing but let's say we have a lot of words. So we are arranging that into this with the particular rule. So we call this rule as a grammar policies. So that grammar policy is known as a syntax for the computer or for the even humans, which making sure that the order of the words make a sense and follow the rules of the language, right? Which is known as a syntax, right? We are doing the same with basically for the programming language as well, right? Then semantic. So syntax is so just imagine in the way that like morphology. Morphology is nothing but the smallest unit like words, right? You have a lot of words, structure of the words. Syntax is something like let's say you have make the policy to arranging the words. So let's say we have a grammar. So let's say you are arranging the word basis on the grammar. So that is known as a syntax. Semantic. Semantic is basically make this point going even more deeper. So we have a semantic. So this is where the computer start to grasp the meaning. So when we are talking about semantics, meaning is going behind the words and sentences. It is like teaching the computer to understand that like hot can means a temperature or attractiveness depending on the context, right? So this is something like example. So whenever you are giving some meaning of the word or something that meaning is represent the context of particular sentence, right? And the no like at the last, let's dive into the fourth name, which is a pragmatic. Pragmatic is basically the art of understanding the language in the context. So it is like let's say teaching the computer to catch onto the unspoken nouns like sarcasm or implied meaning. So pragmatic help the computer to get the whole picture, not just the word on the surface. So basically here we can say that like level of the language analysis. So it is so basically we can say that it is any language, not only the English, computer language or whatever. Any language is derived basis on these four fundamentals. Okay, so first, so let's dive deeply into the morphology. So what is the morphology? So let's dive into the deeply and very quickly. So all right, let's dive into the first level of the language magic is morphology. This is all about understanding how words are built. So like the Lego block of the language, simple, right? So what is the definition of it? So what is the morphology? So it is like a word architect dealing with the structure and formation of the word, and we are talking about the tiniest piece of the meaning called morphologies, morphemes, right? Morphemes is like the building a block that give the words their superpower, right? So now let's break down into the bit more depth. So in theory, morphology is like the word detective. It is identify the uncover agents in the word. So like let's say what is the prefix of word, what is the suffix of word, what is the root word. So these are the secret codes that tells us more about the word job and the meaning. So this is a time for the real life word investigation. So let's take an example of unhappiness, right? So let's dissect it. So here you can see that when we are just breaking down the unhappiness word into the morphes, right? So this process, right, just breaking down the particular original word into the breaking down of the different part, which is known as a morphes. So here breaking down the unhappiness word. So here you can see that un. So un is known as a prefix, which is coming from the starting of the sentence, right? So this is like a superhero, undoing things, right? Then happy is known as a root. Here you are able to see, right? Happy is known as a root word, right? So the core of the emotions. And the suffix nes is adding that meaning touch to the turn into the state of being. See, right? So morphology help us to understand the hidden layer of the word, and it is like solving the word puzzles and discovering the clues that make our language tick. So that's morphology, the word scientist at work. Okay, so now let's see some practical stuff of this. So I will showcase you the code as well with the same. So let me open the code and let me share the screen of my code. So guys, you are able to see the screen, right, of code. Okay, so let me say like how we can do the code of morphology. Okay, so this is a first topic which is known as a morphology. Okay, so as I already told you, you have to extract the word meaning, right? So first of all, I want to introduce you some frameworks, right? Basically, we are using an NLTK framework. NL. So I think that like you all have the awareness of this, right? Python programming and all. And NLTK is one of the famous library. Another famous library is Spacey. Space is very famous library in this domain, right? To do the basic NLP task. So this is basically giving the industrial strength of natural language processing. And also NLTK is one of the oldest library, which is help us to do this all the kind of stuff in very easy way. So first of all, whenever I say that like you have to utilize these libraries and all, first of all you have to install the basic Python one. If you don't know, we will also share one video where you can set up your whole environment, or directly you can utilize a collab, okay, which is provided by Google. So you do not need to worry about anything. You have to directly just open it and directly do the code. So by typing collab you can directly find on the Google collab, and you will find on the Google, right, collab research or something like that. These and this kind of interface will be open, and inside that we can do the code. So basically here you can see that NLTK is one of the world famous library, right, which is contained over the 50 corpus lexicon resources, and there are a lot of functionality, inbuilt function. You can do the classification, tokenization, stemming, tagging, parsing. So we will cover these all the concept by the time when this class is going ahead, right? So in today's session we will see the conceptual based understanding, right? So so how to install this library first. So when you are just clicking over here, you will see that the step. So installation is very simple. You have to just take this pip install. You have to go over here. You have to just take the. You have to just do the exclamatory mark. Not over here. Yes, sorry. You have to do just exclamatory mark, and then you have to do the copy paste. Okay, and now it will start installing your NLTK library. So this is a first installment. Is like how you are installing any library in Python. Okay, instead of this, even you can just direct type in this way, pip install and library name. So let's say I want to install Spacey. I will directly type pip install Spacey. So you can install this way, right? But you can see that already the libraries are already installed over these environment. So we do not need to worry about the setuping environment alone. That's why we have keep this collab environment, so which will make your learning smooth. Okay, so now what we can do is like we are trying to do the programming with NLTK framework right now. Okay, I will also showcase with the Spacey as well, but with NLTK as well. Okay. So first of all, whenever you are installed any library, you have to first install installation is will be done or not. That you have to check. So let's say your installation is already done. So first you have to you have to just utilize this. You have to type directly library name with the import. So let's say pip install NLTK. Okay, so this is a famous library. So once you run cpt enter, so it will showcasing that your library is installed or not. This way you can also check. So this library is already installed, right? So from now we are directly import the library. So let's say you want to utilize any function from this library. So from this library you want to import any function. So let's say from NLTK library I want to import one function that is known as word tokenizer. So by doing the control space, you can get which function is coming over here. So this is nothing but the word suggestions that I told you, right? So this is word tokenizer I want to utilize. Why it is disturbing so much? Let me for now. Okay. Uh, and one more function that I want to use is nltk.stem import. I will do again control space. So it is showcasing the right. I want to use porter stammer. I will tell you everything, right? Which tab I am using. So this is porter stem and word tokenizer. You will understand when we are just going to step by step. So first step is to we have to download. We have to download one corpora, which is known as a font, right? So first of all, let's download it. So you can see that it is unzipping and download is done. Right. Now we want to do the morphology. So first step of morphology is step one. Step one is basically the words. Right. We want the words. And we want to do the word analysis. Yeah, what happened with this? Okay. Word tokenizer. Right. Word tokenizer and we are typing the text. So here you can type any text. So let's say this is okay, and when you are just passing any text inside it, so you have to pass the text by just doing the inverted comma. When you pass this text, it is written like it is just chunking the words into the list format, right? So you can see that it is returning as the list format. Okay, next part is like we have to just convert this word into the original format. So original format is something like, let's say, so for that purpose, we are using a Porter stammer. So Porter stammer is convert the words into the original normalized form. So that is known as Porter. So this is object oriented, this is object oriented class. Okay. So first of all, I have to define the object that is known as a stammer. And I will define the Porter stammer. So when I do the control space, it is coming. Right, so these we are defining. So this is a step 2. Okay, Porter stammer. And now we want to just what we want to do is we want a word original form. Okay, so for that what we are doing is for I need this word, right? So for that purpose I will store this word into the one variable. So let's say this is assist button. So instead of these, I will type one sentence. Okay, that sentence is analyzing morphology is important for understanding language. Yeah, understanding natural language structure. Okay, so here you can see that I have just typed the word and it give the list something like this. Okay, analyzing the words, which is something look like this. Now this is a time we have a lot of words, right? So whenever you have this kind of lot of words, you want to print any word step by step, right? So what we can do is we are using a for loop. So how we can use it? For word in words, right? So let's say we want to print a single word from these all the words. What we are doing is we are doing this and we are just typing the word. You can see that all the word is printed in the sequence. Analogy, morphology is important for understanding the structure dot, right? So this way. Now, here you already know that, right? One by one word is coming. But now we want to print these words original stemma format. So what we can do is we are doing we are just printing another thing, another print statement, and we are applying this object stemma. We are copied and we are just doing a stem operation over here. So stem is something like we just convert the word into the original format. So let's say we have an understanding, so it will convert into the understand or something like. So let's not talk and directly put this word into the picture, right? And after I will do one line, so we can separate each word. Okay. So you can see that analysis, analyzing. So it is converting to the original form of verb, analyze. Morphology. So it's converted to morphology. Ease is obviously ease is a normal verb. So we are using that important. So import for then understanding, understand, language, right? Structure dot is that, right? So these way we are converting that. Okay. So this is basically known as a morphology. We are converting the different kind of postfix suffix word into the original form. So this is known as a morphology. But let's say you want to directly create the function like this. What you can do? First of all, we are using word tokenizer. Okay. So what I can do is like I will just do the define. So this way we can define the word like morphology analysis. You are just passing the text. You are just passing the text over there. You are just passing the text over there, right? So here I will pass one variable text, and then here I will pass words, word tokenizer, word, word tokenizer, right? Here we are also passing this text because ultimately this text is coming over there. Then stammer. So this is nothing but this object. I will copy this object over here. Stammer. Okay, then after what I can do, I will just copy this one for loop. Okay, but instead of that, we are doing it on another way. So that is stems. So what stems is? So we are using loop comprehension. So this will directly make the list of the word. List of the word is like forward, wording, words. So this will work in the same way like what we have done this, right? So this is working in the single line. Okay, and it's written the stems, which is known as returns means any sentence returns something, right? So it's written the stems. And now let's say I will pass any sentence, this same sentence I am passing over here. Okay, and you can see the result, right? You can see the original word, which is a morph, right? We called it a morph, and this way we can do the morphological analysis. Okay, same way in the spacey you can do the same, but inside the spacey it's more easy. So let me showcase you very quickly. So we are same way we can use a spacey. Okay, but here I will directly make the function. Okay, so same way I will give the name sort, right, morph, and I will directly parse the text. So inside the spacey you have to directly define first of all NLP object. So this is a nothing but the variable name, okay, object. So here we have to use spacey.load. So whatever spacey is doing by default, language corpus, which is pre-trained language corpus. So we called it like there is already one data corpora which is already there, which is directly load basically the one object to understand our text. So here we are typing the doc, and now we are using this object. Okay, so let's say we are using these, and then after, let's say you want to understand your own text, so we are directly pass the text. And after that, let's say you want to print the lemmas is nothing but the same like a stems. And in simple language you can say that these are the original form of the words. So let's say understanding, so what is the original word? Understand. Okay, understand, right? So this way we can do. So here we are using token. Okay, here we are using token dot lemma, which is given the original form of the word from token, sorry, not from, for token import in doc. So here you can see that here species provide one corpus, which is a language model, which is something you can say that smart NLP object. Okay, now you are passing your own text. So after understanding your own text, it make a one object which is known as a document. So from that document, let's say you want to extract the tokens. Okay, so that token is already extract, but now you want its original form, right? Original form, which is known as a lemma, or you can say normalized form, or you can say word original form, right? And now then after, what we can do is we are printing, we are returning that lemma, return lemmas. Okay, this is the same like that we have used over here, right? So let me copy this one, do it over here. Let me change the function name. You can see that this is working in the same way. More, you can see that same answer is returning spacey, right? So this is basically known as a lemma. So let's move on the slide. So next you are able to see the next topic, which is known as a syntax, right? So syntax is basically we can say that it's a language architecture. Language architecture is basically that organize a word to make the sentence meaningful. And so in a way that, let's say, just imagine it is like the conductor arranging the notes to create the beautiful melody, right? So what is the definition of syntax? So what is the syntax? So it is like a language engineer examining how words come together to form a sentences. So it is like an art of sentence structure, figuring out where each word belong to create a clear and meaningful communication. Just a minute. Yeah, meaningful communication. So this is basically we call it a definition. But what practically we called it? Okay. But before going to the practically, I can say that like syntax is all about studying the rules of the grammar and how sentences are built. So it is like a learning the dance moves of the language, right? Understanding where each word should step to make the sentence flow smoothly. Okay, so let's dive into the real world example directly. So in the diagram, guys, okay, this is a slide of morphology, sorry. So this is a slide of syntax. Okay, so in the diagram you are able to see that, right, the two sentences. Right. So here we are analyzing the difference between the two sentences. One is the cat chased the dog, or dog chased the cat. Right. So here syntax is action is showcasing that, which is alternative word order changes the entire meaning of the word. So imagine this like a storytelling dance. In the first sentence, the cat is the star chasing the dog, but flip it around and suddenly the dog takes the lead and chasing the cat. So syntax is the choreographer and the word order is a dance routines. So it is simple switch, but it's flip the whole story. Right? That's the magic of syntax. The architect behind the scenes ready for more language revolution. So let me showcase you these in the code format. So let me save the screen again. So you are able to see the code of that. Right, you are able to see, right? Okay. So in the syntax architecture, basically we are using the same framework. Okay. So here we are using the same right syntax understanding. Okay. So we are using again the same framework. Import NLTK from NLTK we are using tokenizer. Tokenizer is tokenize the words. So it is something like splitting the each word by spacing. Word underscore tokenizer, right? So from NLTK, this time we are using import post tag. Post tag is giving us the each word meaning, like in a grammatical point of view, right? As I told you, syntax is nothing but ultimately we are following some grammatical rules, right? So here we are downloading two corpus. One is known as a plunk, not a plunk, PUNKG, plunk, and second one is NLTK dot. Here we have an average. Yeah, this is disturbing so much. Average perceptron trigger. Okay, this is basically the import. This is which is needed to us, right? Average perceptron trigger. This is needed, right? So it is extracting and loading over here. Now, what we can do is like we are just following the steps. So what is the step one? Step one is to same like we have to just splitting down whole whole text into the tokens. So that is known as word tokenizer. So same way we are using the same code. We are not doing anything. We are using the same code. I will do the copy, which make yeah, what happened? Just a minute, guys, because it's in the layout column tools. Single tab view. What's wrong with it? Hey God, it seems the layout. Okay, let me restart it and remove that layout. Sorry guys for inconvenience. This is happening something with the collab. Okay, now you are able to see, right? It's connecting soon. Okay, so we can load it again, so it will just come with the update. And now we are doing the first step, right, which is something that we have to tokenize, and I will also print the words, so you are able to see like, okay, what would be the output of that. So we haven't passed the tags yet, right? So here our tags would be become the syntax structure analysis. So this is the tags I want to pass. Okay, syntax analysis help in understanding the sentence structure, right? So it is giving us the result, something like that. What would be the step two? Step two is like we have to understand the position of particular word, right, which is known as a tag. So what we can do is like we are passing these words into the post tag. You can see that this is showcasing the different sentence structure. This is analysis, VBZ. This is showcasing the grammatical rule based analysis like JJ, NN, VBZ, IN. So these are showcasing the meaning. So let me showcase you the post tag in NLP. Okay. So this is officially like official document where you are able to see that like they are passing one word. John is a so John's big idea isn't all that bad. So John is a name, right? So name is, you can say, the subject, noun, right? Then pose. So this is apostrophe s is known as, right? So this is a JJ, which is something like, you can say that like, which is adjective or something like that. Idea is also the noun. So these way it is separate out each word in the sentence and given the meaning of that, right? That's way it is try to understand like, okay, on the particular sentence, which word is containing the which kind of the like action in that particular sentence. So this is known as a post tagging, position tagging. So for particular word, we are assigning some position tagging as per the grammatical rule. So this is known as a post tagging. And ultimately the answer we are getting is something like this. But what if we can print the tree something for the same? Right. So for printing the tree, I will showcase you the quickly. We are using a spacey. From spacey, we are using displacey, right? And from that, from IPython, these are nothing but the framework, inbuilt framework that is already available. I will showcase you the display. Import svg and display function. I will load it and I will, what happened? IPython is not there. Okay, sorry, P is capital. Okay, and I will solve. Now I will create this syntax, right? And I will just pass the tag to it. Same way, NLP space spacey.load. So what I can do is I will just copy this whole function. Okay, over here I will copy that these two lines, which is as it is, which is nothing but creating the NLP object and then passing our sentence over there, right? So text we are passing, and thereafter we are passing post tag, right, which is giving us a position. So same way we are doing this. So here we want a token dot text, comma, token dot position underscore, which is like an inbuilt function. So from sorry, or token import dot. Okay, and now this is written the positions, sorry, here, and it's written post text, and also it written the doc. Okay, so this is the function we have made. Okay, now this is the time of analysis. So let's say I will just create one text. Syntax analysis help in understanding the sentence structure which is coming from above. Now it will return two things, right? Doc and position of that. So let's say for doc and syntax, syntax on that. So I will pass this function here. Syntax result. Okay, I will pass over here. I will pass this tags, and then after what we can do is like we will print this print docker. What would be the result? You can see, right? This is our main sentence, and then after we what would be the result? So you can see the result will be the same. Syntax is, right, a particular word. Analysis is a noun. Help is a verb. ADP is a ADP means like adjective or whatever it is. So understanding is a verb. Sentence is a noun structure. So it is give the different position meaning to of particular sentence. So particular word which is lie into the sentence. Okay, and let's display like try to create the design for the SVG. You will see like how we can see that display C dot render. We are passing the sentence over there. We are providing a style. Style is a def. We are passing the options. So options. So here we are passing the distance between the two words. Okay, and here we are passing the, let's say, 100 distance we are writing, and we are doing display, and here SVG, right? Ultimately, it is written the SVG format image, right? So that's why I'm passing data and SVG, and then you can see that ultimately it's created the right compounding and add as n subjects and something like that. So it is showcasing the something like in visual format. Okay, so this is a second one which is known as a syntax. Next is, let's move on the presentation again. So let me close that one and open the presentation. Guys, obviously this is a coding phase. Obviously it will take some time. So please don't go, because this is a bit lengthy and taking some time to understand. So if you feel any hesitation or anything, you can share with us in the comment. Okay. So next thing is a semantic. So what I can do is now is I will explain you the two concept, and then after I will directly show the code, right? So that way we can move very quickly. Semantic is like, so now this is the third, right? Third part, semantic. Semantic is something like you are giving the meaning to something, right? So here, where word come alive with the meaning. So it is like being a language detective, like digging into the stories words tells. Right. So what is the what is the definition of semantics? It is like meaning maestro, explaining the depth of the word and the phrases to understand how they team up to share the ideas. Right. Think of it as a decoder ring for the language. Okay, so ultimately in theory, semantic analysis is like putting on our detective hats. So basically, in simple language, we called it like we are diving into the meaning of the word, figuring out what they bring to the conversations, or it's like unraveling the mystery of the language. So like what? So when I tell you something, okay, right now I'm speaking something, right? So ultimately, you are understanding the meaning behind that sentence, right? So that is known as a semantic. Okay, so that is basically the idea of semantic. So here we have taken the example, right, which is a buy and purchase, right? So these are the semantic nouns, buy and purchase. So while both involve acquiring, purchase may imply the formal or deliberating acquisitions. So it is like shopping for words, or buy is like grabbing something casually, while purchase add a touch of formality. So like making a deliberate choice, right? So just a word can change the whole vibe, right? Whole vibe it will change. So semantic is our guide through the word wonderland, right? So this is something which is known as a semantic. Next one is like last one, which is known as pragmatic. So pragmatic is where words not only speak but also the dance to the beat of social and cultural context. So it is like learning the language of unspoken rule. Right. So let's see what is the definition of pragmatic. So think of it as a social wizard language. So it's focused on the how we use words, different situations, considering the vibes of our surrounding. It is like adding the right species to the dish for the perfect flavor. Right. So pragmatic is like a language of anthropologist. So it is explore how language works in a real world beyond just the word themselves. It is like understanding the secret handshakes of communications. Right. So let's say directly go through the example. So let's say here we have take the example of asking for a favor, right? Sorry, not a flavor, it's a favor. Okay, so here the pragmatic use is like asking for a favor, tailoring the language based on how the situation or meaning come into play, right? So here think of it like having a different hats for the different occasions. So when you ask for the favor, pragmatic help you to choose right hat where it's formal or the casual depending on the situation. So let's art of fitting like a language camelot, right? So excited to explore more. Right. So let me showcase you the code based example so you can understand better. Okay, we are in the same screen, right? I mean, so let me showcase you the semantic meaning. So semantic is basically we are using the same NLTK library. NLTK, we are importing NLTK dot corpus. Corpus is basically the collection of the words which is used to do the code, right? Which is a collection of library, right? So for that we have to also download. Here I have to use Chrome and now NLTK dot download, and here I will write word net. You can see it's downloaded, right? Now next step is to we have to create the function, right? Again, so let's say I will create the word semantic analysis, and inside that we are passing the word now, right? Now we are getting the syntax, right? So there is a function in these functions, right? Wordnet dot syntax, these one. So whatever word you are passing inside this syntax, okay, it will give the meaning of that word. Now we want meaningful definition of that particular, right? So we have already defined this object. Now we want to extract the meaning of whatever the word you are passing over here. It will give the meaning of that word. So here what we are doing is we are using a scene, first of all, for scene in syntax, right? This syntax is a list of words, right? Whatever we are passing, and we are taking one word from that, and from that we want a definition of that. So what I can do, definition, we have a function for that definition, right, which is giving us the meaning, and it's return the meaning of particular words, right? Now let's pass any word over here. Let's say apple. There is no definition. Okay, you can see that I pass apple, and you can see that it is showcasing the meaning fruit with a red or yellow or the green skin and sweet to tart crepes with wheaties flavor, right? And native, and it is also showcasing that another meaning of that, right? So ultimately, whenever you want to extract the meaning from the word, right, it is giving you the answer from the that. Same way we can do with the spacey. What we can do is like import spacey, but ultimately we are using this wordnet library, okay? So there is a no meaning to use spacey over here, right? So let's not go with the spacey. I provide so we have already provided the notebook, so inside that you are already seen these code there, right? So try to do the code by your own self for the same, right? Now let's see the pragmatics. Yeah, pragmatic is basically nothing but giving the meaning to the content. So let's say I will import the same library NLTK from NLTK dot tokenize import word tokenize, okay, and from that again we have to download the same. So what I can do, I will do the copy paste, which may this one, okay. So this is downloaded. Now what I can do is I will create the one function, that is pragmatics analysis. Inside that we only have to pass the context, okay, and it will return the. So same way I will create the want tokenize nice, and here we are passing the context, and I will pass one word. I will pass over here is like one word which is urgent, right? Urgent is something which is come in particular sentence, and if that word is come, it is written that like these needs immediate attention, right? Attention. Else it's written please review at your earliest convenience, right? This way we have to analyze. So this is our function. Okay. Now I will provide the context. So context is the document requires your attention. Right. It is, sorry, it's urgent. So when this word is coming, right? So here you can see that urgent, right? This word is coming. Now we have passed this into the pragmatic analysis, right? And copy this. We will pass this context, right? And what result it will bring us for. You can see that this needs immediate attention because this word is coming to the picture. So this is known as a pragmatic analysis. Hope guys you understand this stuff, right? So session become very big. I understand your situation, but yeah, this is the context. So what we can do is like next concept, which I'm sharing on the screen, right? Which is a pragmatics, which is a label analysis is done. Okay. Now I will only tell you the definition, and this for the coding for these language representation model we will do the on next session. Okay, because obviously 2 hour attention is everyone has only the 12 to 15 minute of attention span, and then after we will take the question regarding this. Okay, so here you can see that language representation models. Right, we have already gone through the basic of like a morphology, analysis, then syntax, semantic, and then after the pragmatic, which is giving the context to the whatever context and meaning to the particular sentences. Now, this is known as a language representation model. So let's say you have a list of the words, right? So here let's journey into the realism of language representation model. So here there are tools that help the computer to understand and work with the languages. Work with the languages like imagine them as a different lenses, each offering a unique way to view and interpret the words. Right. So let's say we have a three techniques, bag of words. Right. So bag of word is something like you can just imagine this kind of the one bag. Okay. Inside that you are passing a list of words. So let's say a lot of document you have. You are just separate out each word from that sentence and you are passing inside that bag. And from that you have to now calculate that word. So let's say this is Ashish Patel, this is Vedant, right? The Vedant Pandya, this is Rushabh Patel, this is a lovely Nasir, this is Srinivas Nath, right? You all have that. This is a sentence is common. Now we have to calculate the frequency of particular word. So this way we can calculate that what is the number of word repeat in particular document, right? So here we have a three part bag of the word, TF-IDF, and word embedding. So this is known as a language representation model. So and let me give you the core idea of what is a bag of word, TF-IDF, and word embedding. So just think of, so let's think about the bag of word first. So think of like a language snapshot. It's break down the sentence into the individual word. Okay, so let's say this is Ashish Patel. So I will break down this is Ashish Patel. Okay, ignoring their order. Okay, it's like creating a word inventory without caring about the story structure. Right, that way bag of word is working. TF-IDF, term frequency inverse document frequency, right? So these one adds a touch of the importance to the word. So TF-IDF is not only the count the word frequency inside the bag of word. We have counted like okay, particular word repeating how many time in particular story. Okay, but in TF-IDF, we are not only count the word frequency, but also consider how unique words is across the different documents. So let's say you have a five story. One story is for the let's say Tom and Jerry story. One story is for let's say Scooby Doo story. One story is for let's say Popeye the Sailor Man story. Let's say one story from the Panchatantra, one story from the right. So there are a lot of stories we have. Let's say we have five storybooks, and from that we are calculating how many unique words come into the picture, and we are also calculating that unique word frequency, right? Let's say particular unique word how many time repeats in whole five documents. Okay, so let's say one word Tom is repeating let's say 1000 time in particular story, or let's say 200 time. Okay, so that Tom is come uniquely, right? But that is not come on other document, but still it is a unique and it is repeating 200 times, so that is known as a frequency of that particular word. So that's why it is known as a term frequency and inverse term frequency. And so here we can TF-IDF is not only count the word frequency but also consider how unique a word is across the different document, and it is like highlighting the word that brings something special to the particular conversation. So when we are talking about Tom and Jerry repeating on particular story, we can say that this story is all about Tom and Jerry, right? So that way it is giving the special, like bring something special to the conversation and make them stand out, right? And the last one is a word embedding. So now imagine word. So imagine the word in a dance. So word embedding capture in a relationship and meaning between the words, right? So it is something like relationship and meaning between the words by representing them as a vector in a multi-dimensional space. Multi-dimensional is like 2D, 3D, 4D, 7D. Okay. So it is like teaching the computer to understand word, not just individually, but also in the company they keep, right? In the company they keep. So this is the model like language detective, each with its own superpower. Bag of words simplifies, TF-IDF values the uniqueness, and word embedding dives into the dance of the words. So this is basically the fundamentals, right, which we are trying to giving the word to life, right? These we are just trying to keep this. So I will quickly go through it. So within a 10 minute we will complete this or three scenarios, right? So let's unravel the mystery of the bag of words. As I already told you, right, we are calculating the frequency. So here in this on the screen you are able to see that, like, so what is the definition of bag of word magic? So it is a way of representing the text where we care more about the words or less about their orders of the grammar, right? Again I am repeating, it is a way of representing text where we care about the words or less about their order of the grammar, right? Think of it as a language snapshot, right? Again same example, and capturing the frequency of each word in the sentence. So here so in theory they have given the definition is like bag of word break down the whole text, or we can say the whole sentence, into the small chunks, and then after they're counting frequency of that particular word. So imagine each word getting count, like telling how many times they are appeared in particular sentence. So it is like creating the word inventory, caring about how much each word shows up, right? So here I will give you the one example. Here we have a like a one sentence, right? The cat chased the mouse. So here you can see that we have the cat chased the mouse, right? So it is a four word sentence, right? So here we are remove the keyword, right? Or let's say we keep the. Okay, so the cat chased the mouse. For that purpose we are just representing 1111, which is giving us the counting frequency of each word, ignoring the orders. Okay, ignoring the orders, because here we are not care about the grammatical order of particular sentence. So picture it is like a sorting through the bag of colorful marbles. Each marble we called it a words get counted, and we ended up with unique count for each, right? So that's the bag of word model, simplify the language into the friendly and straightforward form. So one question we are getting, right, from the from whom, yeah, Jay has asked one question, what type of not that one. One question we have is like a Russell or maybe, so like it is regarding like for every text we are applying a NLP to just identify the, like NLP can apply on every text. So yeah, this way we can identify the different kind of the analysis. So here you are able to see that like we have a text data and you want to count the, let's say, how many time particular word is repeating. So that time we are using the bag of word kind of the technique, right, which is give us the meaning to the particular sentence. This is a TF-IDF, right? Term frequency, inverse term frequency. So we called it a welcome to the world of TF-IDF, the language detective that helps us to find the stars in the sea of the words. Right. So it is like assigning the spotlight on the important player in the language game. So okay, spotlight on the important player in the language game. So basis on that, what the definition you can imagine. It is like a word VIP pass. TF-IDF evaluate how crucial a word is in a document by looking at how often it appears there compared to its frequency across many documents. So it is a way of saying that, hey, this word is a special in this particular context, right? Let's say theoretical definition of it is like TF-IDF is a double agent. It is a consider both term frequency. So what is a term frequency? Term frequency is how often word appear in document. So here consider the document as a, let's say, one sentence. Okay. So let's say we have in the in like in on the screen, right? You are able to see one example, right? On that example, let me try to zoom it out if I can. Maybe I don't. Okay, so that example, let me tell you, I'm not able to zoom it. Okay, guys, sorry for that. But I will tell you that example. So here we have a two sentences. Okay, basic Linux command for the data science. And second sentence is like a essential DBC command for the data science. So these are the two sentences. So one sentence is known as one document. Second sentence is known as second document. So when I called it TF, term frequency, so we have to calculate how often word appear in particular document. So here you can see that in the table we have extracted the unique words: basic, command, data, DVC, essential for Linux and science. Okay, so it is trying to calculate how many time particular word is appear in the document, right? And second, so this is something counting, unique counting for particular word. Okay, and now uniqueness of that word. Uniqueness is like how rare the word is across many document. Okay, so how many times this word is repeating on particular document. So let's say in the first example, basic Linux command for the data science. In the second example, essential DVC command for the data science. So here you can see that command for the data science is repeating constantly. Okay, so this is known as a inward term frequency, which is known as uniqueness. So it is like a language critics, which is to value the word not just for how often they say it, but also their uniqueness, right? So so let's say basis on the sentence you are trying to compare. So from first word, how many word is getting similar? So here you can see that basic getting the similarity zero point 0.5. So this is calculating the distance, right? How much similar they were to are. So behind that, there is a one mathematical term used, cosine similarity. You can explore by your own self in easy language, right? It is calculating the distance between the two and giving the similarity between 0 to 1. Okay, so here you can see that zero point 0.5, which is like a high similarity we are getting in the from sentence one. Then after command, data, right? Data science data is there. DVC is not there, so 0. Essential is not there, so 0. 4 is there, so 0.35. Linux is there, so zero point 0.5, and science is there, 0.35. Same way we are giving the distance of the particular word, right? 0.35, where the sentence a particular chunking word is there. So this is showcasing that to identify the significance of a particular word in a document containing the multiple occurrence of term, right? So this is something example that, right? So you can imagine these in the way that, like, imagine like having a celebrity in a small town. They stand out because they are not everywhere, right? So TF-IDF is our guide to spotting the language celebrities, the word that truly matters in the specific piece of text, right? So this is known as a TF-IDF. I hope you understand. And the last one is known as a word embedding. So again, I will tell you, welcome to the world of word embedding, where words transform into the vibrant vectors, right? Capturing their meanings and relationship. It is like giving a word a special place in each continuous landscape. Okay. So what is the definition of word embedding? As you already understand, right? Counting the word from particular document or particular sentence, that is known as bag of word. But now let's say you have to also add one more feature, that is uniqueness. So when you are calculating the uniqueness with a particular word count, that is known as a TF-IDF. And now third one is a word to vector. So think of them as a word superpower. Okay. Like in simple meaning, we can say that it is like a giving a word a special place in a rich and continuous land space, right? So here, basically, word embedding. So, what do you think? What is a word embedding? So, I think we should think as a, like a word superheroes, right? They are representing the word as a dance vector in continuous space, right? You are able to see on the screen, right? That is a something space is there. Are you able to see? Yes, right. So think of as a word superheroes. They represent the word as a dance vector. Dance vector is nothing but the one vector where you are see that, right, there are a lot of zeros and one is there, which is known as a dance. You can also call it a sparse matrix in a mathematics. Right. So these word dance vector in a continuous space, not just focusing on individual word, but also on their connection and the meanings. So it is like putting the words on a map with coordinates, right, allowing us to explore the vast landscape of the language, right. So basically, in simple term, we call it like this is a magic glass. Magic glass is like they are providing a dance context aware representation of the word. So it is not just about what word is, but also about where it fit in a particular context, right. So like giving a word a 3D personality. Okay, let me give you the example. Okay, just imagine one thing. There is a king and the queen. Okay, these are the two words, king and the queen, in a word embedding, right? So they are very close. They are the very close. Okay, just imagine and that way. King and the queen are the very close. Okay, okay, now it is reflecting the semantic similarity. Semantic similarity means this word has their own meaning, right? So imagine these vectors like a star in the word galaxy, and when king and queen are close, it means that they share a special connection in a meaning. So when I'm talking about king and queen, you are just imagining the one story of the of like a king and queen, right, or whatever, right, whatever kind of the story of any king and queen. So which is give the semantic meaning of particular story, right. So this way it is sharing the particular relation or special connection in meaning. So word embedding is open the door to the world where words not only have a meaning but also the relationship between them. So here you can say that when I tell the king and queen, it is also sharing some relationship in meaning, right. So this is known as a word embedding. So on screen you are able to see that, right. On the screen you are able to see that like the man whom swore something like that. So this is a nothing but the one matrix. So on the left side you are able to see the center words, the man who, right, something like that. And same way, we have a one layer which is known as embedding layer. So these word you have these word like chat gpt and all, right, you all using and everything you are able to see on like how chat gpt is giving the particular context and powerful responses for the particular question you are asking, right. So this is the word to vector. So this is word embedding is one of the like a technology used behind the chat gpt, which is give this robustness to the chat gpt or like any other technology, something like let's say perplexity.ai, bard, gemini model is there. So this word embedding is one of the most powerful like tech I can see, which is like from this LLM era, right? And after this next session, we are able to see the code of these three, right? Bag of word, term frequency, inverse term frequency, and also the word embedding. Okay. Now, if you have any questions, you can ask, guys. If you have any questions, you can ask. You can ask in the chat as well.
Yeah, so thank you so much once again for the wonderful session, Ashish.
It's so lengthy, but yeah, guys, I understand and I respect your patience specifically.
Yeah,
When we have to understand, we have to keep patience while learning this kind of the concept.
exactly. And
Okay,
we can say
guys.
it is the introductory session. So this is something which everyone knows, but as we are going it with practical examples and coding along with the sessions, this is going to be a good one.
Yes.
Okay, so we have
Yes.
our first question. Let's
So we
see.
have a quiz. Yeah, we have a question is like, can we
Yeah,
have this code to do practice? Yes, Rusav, we have said already in
yeah,
email. So you can get this code. And also I said one link there, which is provide you the more advanced, like which is a core fundamental coding you can understand from there. So link
yes,
is already said. If you want to see, you can just see this link. GitHub
exactly.
repo for this lesson is like you can just go there and just do the star for the same. Any other have any questions?
Okay. So the question is, what extra practice require to have good hold over the topic?
Yes. So basically, NLP is a very big as a, like as a Vedanta showcase the big picture, right? Big picture of NLP. So Vedant, can you showcase it again or like
Yeah, just give me a minute.
yeah, please
I'm
showcase
doing it.
them.
Yeah,
So by doing the practice of code and just playing with the text or playing with the NLP examples, you will understand that which concept used where. Okay, that way only you can understand, right? But by the time we are also showcasing you the flow, which is a repeat process. So here in the coding, you have see that always we are doing when I provide any sentence, ultimately we are doing into the chunkings, right? And then after doing, we are doing any operations. So ultimately we are converting any sentence into the list, and then after we are doing the operations over that. So
yeah,
yeah, Vedant have said this picture. Okay, so Lavanya, you are able to see that this big picture contains a lot of topics, right? Lot of topics in the sense like which to use when. Okay, and by the time from understanding the basic, we are also sharing this PPT with you, like with everyone, so you can even explore that, like okay, what is the meaning behind particular thing. You can even understand the text, you can understand the concept by reading yourself. Okay, and we are also trying to share one trying to send one notes. We are not promised yet, but yeah, by the time if we will get some time, we will also prepare that. So this is a whole map of natural language processing. You can see the different basics. Basics is something like you have to understand the recursive models, recurrent models, distributed representation, task specific like post tagging we have seen, then also language models, encoder models, decoder models, state of art NLP, right? So there are very this is a very diversified branch. Okay, so that's why we have focus over here is like main thing which is directly utilized and which is help us to understand large language model fundamentals, right? So that's why we have started and choose the concept like this, so you can understand only that fundamentals for the purpose of understanding the large language engineering, right? Large language model engineering. So that's why we are just taking this concept. But whatever the coding we are sharing over here, that will you can do the practice for the same. And also I have said one link on that language analysis notebook, which will give you the all the type of NLP concept, fundamental concept coding. Okay, so try to explore that article and do the practice for the same. Okay, yeah, this is the answer of your question. Any other questions? Okay, I think Vedant, we should conclude this because
yeah,
time
sure.
is already there is around a 2 hour session conducted.
Yeah.
Okay, guys, thank you so much.
Okay, thank you so much,
See you on
guys.
the second session. Hope you will support us, and next time we will try to improve the session as well because this is the first one, so we are trying and testing a lot of things. So we
Yeah,
need your support. Thank you so much.
thank you so much, guys, once again.